Unlike the previous control strategies, the PWM control technique generates a series of control pulses with modulated width. To produce the control pulses, we need two signals, which are modulation or reference signal and carrier signal. The reference signal indicates the desired wave shape of the output voltage of the inverter. Typically, the wave shape of the reference signal is sinusoidal. Thus, by considering the reference signal, the control technique is known as a SPWM control technique. The reference signal has a fixed low frequency and a fixed amplitude. Normally, the frequency of the reference signal is following the power grid frequency, which is 50 or 60 Hz. This frequency will determine the inverter output frequency. Meanwhile, the amplitude of the signal is depending on the load voltage requirement. For the carrier signal, the wave shape of the signal is triangular. In opposite to the reference signal, the carrier signal is a high frequency signal with fixed frequency and fixed amplitude. In general, the frequency of the carrier signal depends on the type of power switches used to construct the inverter. And the frequency of the carrier signal will determine the switching frequency of the inverter. In overall, you must be able to differentiate between the output frequency and switching frequency of the inverter. Both frequencies are referring to different parameters. Typically, there are two types of the carrier signal, which are unipolar and bipolar carrier signals. The unipolar signal is normally in W shape and it has a positive amplitude only. Meanwhile, the bipolar carrier signal has an M shape with positive and negative amplitudes. We can compare the PWM control technique with the previous control techniques based on the number of input signals needed to generate the control pulses and the width of control pulses. In practice, you can use signal generators or other controller circuits to generate the input signals for the control technique. Now, I will show you how to sketch a PWM control pulses based on specific reference and carrier signals. Let's sketch the signals together. First, we will sketch a 50 Hz unipolar triangular carrier signal and a 50 Hz sinusoidal reference signal. Based on the reference signal, the inverter will produce a 50 Hz sinusoidal output voltage waveform. Hence, in a complete cycle of the inverter operation, we will have one cycle of the reference signal. By applying a cross multiplication, we need to draw 10 cycles of the carrier signal. You should start your drawing with the carrier signal. By using Vc as an amplitude, you can sketch the carrier signal as follows. Once you have a complete carrier signal, split the signal into two areas to label pi and 2 pi's. Then you can sketch the reference signal. In this exercise, the amplitude of the signal is positive and negative VR. Later, we will sketch the PWM signal based on specific rules. The rules can be changed according to the system requirement. According to the first rule, whenever the amplitude of the reference signal is equal or higher than the carrier signal, the amplitude of the PWM signal is equal to 1. However, based on the second rule, the amplitude of the PWM signal is 0 when the amplitude of the reference signal is lower than the carrier signal. To compare the amplitude of both signals, we need to sketch a line at every intersection point of both signals. According to the rule, the PWM signal can be sketched as follows. Now, we will apply the same procedures to generate a PWM signal using bipolar PWM control technique. According to the switching frequency, we need to sketch 5 cycles of the carrier signal only. Next, label pi and 2 pi's. Then, sketch the reference signal. According to the same rules, we can sketch the PWM control passes as follows.